Hello everyone, welcome to Mayu Programming Club. Today we will be solving the problems of weekly contest 363 on Leetcode. So let's solve the first problem of the contest. So the first problem name is sum of values at indices with k set bits. So you are given a zero indexed integer array nums and an integer k. You have to return the sum of the elements in this nums array whose number of set bits is equal to k. So you have to return its sum. For example, if you take uh, not those elements, actually the indices of those elements are having exactly k bit set in their binary representation. So if you take this particular example, so the index of 5 is 0, 1, and 1 is the index of 10, 2 is the index of 1, 3 is the index of this 5, 4 is the index of this 2. So, and their binary representations are given. So you have to check for only a number of one set bits. Only one set bit should be there. So these two are having one set bit, and these two, and this one is also having one set bit. So indices 1, 2, and 4 are having one set bit, and the numbers at those indices will be added and returned as answer. So this is what we have to do. So what we will do is we will simply run a single loop, and we will use the sum variable to keep the sum of the variables. So some of these numbers which are having whose indices are having k bit set. Now these are the indices of the nums array. So if the indices, this is a inbuilt function in C++. To count the number of set bits. In Java, it would be a implementation. So I will be providing a link for that implementation. In C++, a built-in function is provided to count the set bits. So if the number of set bits is equal to k, then we will add that number to the sum, and we will return the sum. So it's getting some error. Okay, it's nums. Yeah, answer is getting whatever is expected from us. Our answer is returning that. Let's try to submit it. So it's getting accepted. So let's move to the second problem of the contest. So I hope you are able to understand. Only those, let me change the theme. Only those indices whose number of set bits is k will be considered. So this is the second problem of the contest. Happy students. So the problem statement goes like this. You are given a zero indexed integer array nums of length n. Okay, integer array will be given to you, this array, where n is the total number of students in a class. The class teacher tries to select a group of students so that all the students remain happy, and there is a criteria for a student that will remain happy. If the student is not selected, the total number of selected students should be strictly greater than. If the student is selected, then the total number of selected students should be strictly greater than the value present at that index in the students array, or this nums array actually. So, and if the student is not selected, the total number of selected student is strictly less than the value at this particular index in the nums array. So what's the problem statement is saying is, let's say array is given to you. Let's say this array is given to you and we mark the indices. Now let's denote these indices by index. Now the student at the index, any index, will remain happy if type of students should be remaining happy. Selected students and not selected student. Selected for first one. Selected student will be remaining happy if number of students selected is strictly greater than nums of index. Student at a particular index will be happy if this condition satisfied, if he is selected student, and this is the nums array. For unselected student or not selected student, number of selected student should be strictly lesser than nums of index if the student at this particular index is not selected. So this is what the problem statement is saying till now. Then you have to return the total number of ways such that everyone remains happy. So you have to return the number of ways to make selections so that everyone remains happy. Now, if you carefully observe that in this particular problem, this particular value determines whether a student will be happy or not. Value at nums. So, if we sort this nums array according to increasing values of nums, then we can make some observations, and according to that we can arrive at our answer. So what we will do is we will sort this nums array in ascending order. This nums array will be sorted in ascending order in this direction, or say increasing order. And what you will do is, let's say I make a partition. All the students on the left hand side of this partition are selected, and all the students on the right hand side of this partition are not selected. So this partition can be ranging from 0 to either you can place this partition here if no student is selected, or you can place in any of these positions. This partition can be placed anywhere. So what you you can try to place partition according to the indices of nums array. So you can have a single traversal of nums array and try to place partition at each index. And if all students are happy in a particular placement of partition, then a number of ways will be incremented. Number of ways will be incremented. This is the logic that we will be applying. Let's try to understand the logic with the implementation. There it will be more clear to you. First of all, we are sorting the array or nums array because students being happy depends upon array values, and sorting it will make or placing of partition easier in order to divide students among selected and not selected ones. And then checking if everyone is happy. Now further you will see why this sorting will help to check whether everyone is happy in a particular placement of partition. So if the first number of this nums array after sorting happens to be greater than 0, then it means that we can make 0 selections and all of the students will be remaining happy. So this is for that check. Let me quickly zoom out so that you will be able to see the entire portion of the code. Should be fine. What you will do is, according to your partition, you will select a few and not select rest according to partition. And this partition is nothing but current value of index. So at each index, you will try to make a partition by including, so at each index, you will try to make a partition so that till that index, the students are selected and remaining ones are not selected, which are on the right hand side of partition. Okay. Then first you will be checking if the students are happy. Selected students. This is the condition for the selected students. In each step, you will be trying to select more and more number of students. And if now once the selected students are happy, you will check if the not selected ones are happy. And if that's the case, you will increase your number of ways. And if you are selecting all the students, none of the students is not getting selected, then you will also increase your number of ways. At last, you will return your number of ways. So that's for the solution and the approach. If you are still having any doubts, please feel free to ask them in the comment section. Now let's move towards the third problem of the contest. And also the time complexity here will be n log n. N is the size of the nums array, which is 10 raised to power 5. So those of you who do not know how the time complexity of accepted solution varies according to input size, I will be providing a link of an article where it will be explained. Basically, what I can tell you is your number of operations was 10 into log of, because sorting will require this much time complexity, log of 10 is to power 5 number of operations. So this is the time complexity or the number of operations of your solution. And it is well within the bounds of, is it less than 10 is to power 8 number of operations. Allowed in 1 second. So if the number of operations of your solution is lesser than this limit of number of operations, then you will get a accepted solution. Otherwise, you may get a TLE and your solution will not be accepted. Sorry for this glitch. So this is a particular limit that is being set for the number of operations allowed. You can explore this article that I will be providing link for, and then you will be able to understand in a much clearer way. So let's move towards the third problem of the contest. Maximum number of alloys. So challenge statement or problem statement goes like this. You are the owner of a company creating alloys using various types of metals. There are n different types of metals available to you, and you have access to K machines that can be used to create alloys. Each machine requires a specific amount of each metal. So every metal will be required by every machine, and a specific amount will be required to create an alloy. So for the ith machine, to create an alloy, it needs composition Ij, units of metal of type J. So array will be given to you, which is composition Ij. So the value at this particular array, let's say its value, and J is the type of metal. J type of metal, you will require this much number of number of units to make alloy. So I hope you are able to understand. Initially, you are having a stock of each each type of metal, which may be from 0 to, but it is the range from 0 to 10 raised to power 8. And purchasing 1 unit of metal will cost you cost number of points. So basically composition, stock, and cost. These three arrays will be given to you. Stock is the stock for each metal that you are having. Cost is the cost of 1 unit of metal that will cost you if you decide to purchase it, a particular 1 unit of metal. So what you have to do is you have to return the maximum number of alloys that your company can create with staying in the budget number of points. So you are only having this much number of points, and K will be the number of machines, N will be the number of metals, and this will be the composition requirements for each metal that each machine will be requiring. This is the composition requirement for first machine. This is the composition requirement for the second machine. And these are the stocks that are available for different metals. And these are the cost of 1 unit of different metals. So you have to return what are the maximum number of alloys that can be created with staying in the budget. So let's try to solve this problem. What we will do is, first of all, let's have a look at the constraints of the problem. So N and K will be of order 100. Your budget will be from 0 to 10 raised to power 8. Composition will be of length K, and these constraints are not very much significant here. This one is stock value will be of order 10 raised to power 8. So if I say that from this stock value and this budget value of order 10 raised to power 8, and your budget was of order 10 raised to power 8. So from this it can be said that the number of alloys that can be produced will vary in range 0 to, let's take a upper bound 10 raised to power 9. So this much I can say that your will number of alloys will be lying between these two values. So this will be the range for the number of alloys that can be produced. So what we will do is we will binary search for the number of alloys. That can be produced. And in binary search, how you will reduce your search space? Those of you who are not familiar with binary search, I will be providing a link for an article describing binary search. So how you will reduce the search space? If there is a machine which can give you number of alloys that you are proposing, as your answer, with staying in the budget, then you can check for higher post values of number of alloys, higher number of alloys. And if that's not the case, you will check for lower number of alloys. So according to this particular answer, that whether a machine can give you number of alloys that you are proposing uh, with staying in the budget, according to that you will reduce your search space in binary search, and the overall time complexity will be uh, k, which is the size of composition array, k into log of 10 raised to power 9. And k is 100 into log of 10 raised to power 9. So let's see what log of 10 raised to power 9 is. Three, 4, 5, 6, 7, 8, 9. So this is 10 raised to power 9, log of 10 raised to power 9, 29. So it's very much within the range of this particular limit of number of operations. So your solution will be getting accepted. And one thing I forgot is, since it is a 2D array, this composition, so it will not be actually k, it will be n into k, where n is the number of metals. It will be n into k. So another 100 can be added. Still, it will be lesser than 10 raised to power 8 number of operations. So that's the time complexity, and we will get IC's accepted solution. So let's have a look at the implementation. We will binary search for number of alloys that can be made and try to maximize it using binary search. Try to find the maximum value. Find its max value using binary search. So number of alloys will vary between the number of alloys will vary the range 0 to 10 raised to power 9. So this will be the range that the number of alloys will be varying. And to reduce your search space, you will check if a machine is able to give you num alloy number of alloys while staying in budget. Then you will check for higher values of number of alloys. That can be possibly made. And vice versa. So this is a standard binary search with a little tweaks. This is a function to check whether your the money that you will be spending on making the alloy will be in budget. The money that a particular machine will spend to make alloys, number of alloys is within budget number of coins. So if that's the case, then you will return true if any of the machine is doing so. If any of the machine is able to do so, Otherwise, if none of the machine is able to do so, you will return false. And at last, you will be returning your result. So that's the solution and the approach. If you are still having any doubts, please feel free to ask them in the comment section. Now let's move towards the final problem of the home test. So the problem's name is maximum element sum of complete subset of indices. So set of numbers is complete if product of every pair of its elements is a perfect square. So let's say you have a set of numbers A, B, C. Then every pair product should be a perfect square. So AB, BC, and AC. These will be the pairs. So their products should be perfect squares. Perfect squares are like 16, 4, 25, 100. It's perfect square 8 into 8, 16, 2 into 2, 5 into 5, 10 into 10. So like this. So you have to set such a set of numbers and set of indices. From nums array, which will be given to you. And if a particular set satisfied this condition, if a particular set is complete, then you will take sum of values at this set, values of elements at the indices of this set. Let's say indices elements were E1, E2, and E3. So the sum will be E1 plus E2 plus E3. And you have to tell what will be the maximum sum possible. Maximize it. First of all, we have to make a little observation, which will be, let's say a particular index can be represented as a, something like this: 2 raised to power 2 into 5 raised to power 2 into 3 raised to power, let's say 4 or 7. Then if you remove all the perfect squares, 2 is a this 2 raised to power 2 is a perfect square, 5 raised to power 2 is a perfect square, and there 3 raised to power 4 was a perfect square, which was 81. It was 9 into 9, and then 3 raised to power, actually 3 raised to power 5. Yeah, till this one. Just a second. Yeah, for this particular one, 3 raised to power 4 will be a perfect square, and then 3 raised to power 3 will be separated out, and after deleting all the perfect squares from this particular number, you will be left with this one only. So if let's say there is another number, and after deleting all the perfect squares from that number also, you are having something like this: 3 raised to power 3 into 3 raised to power 3. So If you take a product of these two, you will be having something like this. It will be a perfect square in itself, because 3 raised to power 327 into 27, so it will be the square of 27. I hope you are able to understand what I am trying to say. So if you the observation is, if you remove perfect squares from every number, from every index value, then uh, let's say x is what remains after removing perfect squares from index value. Then all the numbers in a set will be having this x residue only, and when we multiply such numbers, we will have a perfect square. Such numbers with each other will have perfect squares. Or say when we will pair such numbers with each other, we will have perfect square. So that's our observation. The whole solution is based upon this observation, that when you will remove all the perfect squares from a particular index, the residue that will be remaining is the residue that should be present in every numbers that is trying to form a set with this particular index. And all the indices which are having same residue, for all indices which are having same residue x after removing perfect squares from index value, uh, we will sum their elements, and at last we will be returning maximum sum, and return maximum sum possible. So more will be clear to you in the implementation part. Now let's have a look at the implementation. So this is the implementation. You can say odd residue. Or say odd power residue. So this map will be used to store the sum of all numbers which are having same odd power residue. So from every index value, remove all the perfect squares it uh, and then add the contribution of this index to the subset that will be consisting of to the complete subset that will be consisting of this index. So it will be the contribution of present index to its complete subset. And this is we removing perfect squares from current index value. And it's mentioned that the indices are from one index indices. So index value will be 1 plus 0 based index. So that's this is we removing the perfect squares. And yeah, that's it. Along with that, keep updating max element sum. You can replace this result with max element sum. So that's pretty much it. Let's try to submit it once. As you can see, it's getting accepted. So that's all for the video. And if you are still having any doubts of in any of these solutions, please feel free to ask your doubts in the comment section. I will be more than happy to answer them. Thank you for watching. Thanks.